It is possible to store functions as property values of objects. This type of function is referred to as a method. We have already been using methods since the Hello World program, but I didn't call it that before. The console is an object and log is a method. We can also define our own methods. This code follows the usual structure of property name followed by a colon and followed by a value. In this case, the value is an anonymous function, which is why there is no function name immediately after the function keyword. It is actually possible to put a function name there, but that is only needed if the function calls itself, which is a topic we will cover at a much later time. In most situations, that isn't needed, so it's common for the function to be anonymous. Note that the property name is not the function's name. This is similar to assigning an anonymous function to a variable, and that variable's name is not the function's name. We covered that point in a previous video. There's a shorthand syntax for defining methods which omits both the colon and the function keyword. This code is identical in meaning to the other more verbose version, and it is currently the most common way to write methods. It is common for methods to make use of values contained within the same object. This requires a self-reference. One possible way is to access the property the same way as you would from outside the object. This approach can work in some situations, but it's problematic because the name of the object must be known in advance. Some situations can arise in which the name is not known in advance, and it's possible for an object to never have a name. The anonymous object function returns an object that doesn't have a name. This object is then used in a console log without the object ever having had a name. To refer to the object that a method is in without actually naming the object, we can use the this keyword. The sum method is able to access the values in the object by using the this keyword. Trying to use the actual name of the object would not work because this object doesn't have a name at the point when the sum method is declared. It is only accessible with a name later, which could be unknowable depending on how and who uses this code. Note that the creation of an intermediate variable could be omitted by chaining the method call. The call to anonymous object returns an object, and the call to the sum method is chained onto the function call. When written this way, the object actually never has a name at all. When the this keyword is used inside a non-arrow function, the object that it refers to depends on how the function is called. In the previous example, the function was called as a method of an object, so the object owning that function is what the this keyword refers to. In this example, the getNumber function is declared in the global scope. Both the lucky and unlucky objects have a value called getMyNumber, which contain references to the same getNumber function. Despite executing the same function, the two console logs produce different outputs based on the object used to invoke the call to getNumber. Here is another example. In this one, the method is defined inside the object, but it is called in two different ways. This code assigns the getNumber function to numberGetter. Note that no parentheses were used, which means numberGetter has the function and not the function's return value. Calling getNumber directly outputs 42, but calling numberGetter outputs undefined. If we follow the same structure but with a method that just returns the value of this, we can see that calling obj.getThis returns obj, but calling thisGetter returns the global object. The global object we see here is the Node.js global this object, which holds the global values. Running the same code in a browser outputs the window object instead, which is the global object for browsers. Note that running this code in Node.js can also output undefined if the code is run as a module. That is a topic we will discuss at a later time. For non-arrow functions, it is possible to bind the value of this to a specific object. The binding specifies which object that the this keyword refers to. We use it here by adding .bind to the function name followed by parentheses. Inside the parentheses, we place the object that the this should refer to. It is possible to bind the method of one object to a different object. In this code, the getNumber method from the unlucky object is bound to the lucky object. Note that this binding does not affect the original method. Calling getNumber on unlucky still returns 13. The binding is only for numberGetter. If you want to temporarily provide a value for the this keyword without creating a new variable, use the apply method. This code calls the getNumber method belonging to the unlucky object, but the apply specifies that the value of this is the lucky object. The result is that the code outputs 7, which is the value of my number for the lucky object. If I substitute apply with call in this example, the result is the same. Both call and apply allow for specifying a temporary binding to the this keyword. They differ in how parameters are passed. The total method in this example adds 2 numbers to the value of my number. The first invocation is direct, so it uses the value of 13. It calculates 5 plus 10 plus 13, which is equal to 28. The next 2 invocations both create temporary bindings to the lucky object, so they use 7 as the value of my number. They calculate 5 plus 10 plus 7, which is 22. The difference is that the call uses comma-separated values and apply uses an array, which is the reason for the brackets. We will cover what arrays are and how to use them in a future video. Arrow functions do not create their own binding for the this keyword. They instead use the value of this from the outer scope. It is generally recommended that you do not use arrow functions as methods, although it's possible to do, and there are some special circumstances when using them is easier. Let's take a look at why we should not use them. The getNumber function returns 42, but arrow getNumber returns undefined. Arrow functions do not have their own value for the this keyword, so they take the value of this from the outer scope, but the immediate outer scope doesn't have a definition for this either, so this dot my number is undefined. It is possible to have methods in nested objects, but it is generally better to place the method in the outermost object if nesting is present. The value of the this keyword will be the object that directly contains the method and not the outermost object. If the method needs to access any values from outer level objects, it is necessary to provide a reference to the method beyond relying solely on the this keyword. Running this code outputs 7 and not 42 because getNumber belongs to the inner object and the inner object's my number is 7. If you needed to access the my number that belongs to the outer object, you could use binding. The bind causes this to refer to the outer object and the outer object's my number is 42. There is a special type of method known as a getter that allows you to get a value from an object without the normal use of parentheses that follow a function call. In this code, the get keyword indicates that number is a getter. Notice the lack of parentheses when calling this function. This allows the user to treat number like an ordinary property, and it makes no difference to the user if the value is a number literal or a function that returns a number. The usefulness of getters might not be obvious when they simply return a value that could be accessed directly, but it has uses. One use is for converting a value before returning it. In this example, temperature is stored in Celsius, but users might want Fahrenheit. It would be possible to use an ordinary method to return the Fahrenheit temperature, but the getter allows the user to not need to know that this is a function call. Note the use of the underscore in temperature. This is a traditional technique to indicate that the value should not be accessed directly, but this is only a tradition and it is not enforced by the JavaScript engine, so the value could be accessed directly. The extra getter for temp-c may seem completely useless, but it allows for the possibility to rewrite the implementation of this code. For example, it might be decided in the future that the internal store should be in Fahrenheit. Note that temp-f and temp-c still give the exact same outputs after the internal implementation was changed, but the direct access to temperature now gives 68 instead of 20. This is the reason that getters might be used even when they only return the internal value directly. It allows for future changes of implementation without any need to change external code. A getter can only be used to get a value, and it cannot be used for setting values. Attempting to set a value using a getter results in nothing happening, or it can cause the program to crash when using strict mode. We will discuss strict mode in a future video. For setting values, we have something similar to a getter that is known as a setter. The set keyword is used to indicate that the method is a setter. Note that the getter and setter can have the exact same name, and it is common to do this. Setters are also able to perform transformations on the input value before storing them. The previous temperature example with setters would look like this. Setters for both Celsius and Fahrenheit are provided. This allows for the possibility of future revision in which the internal value changes. It is currently set up to store as Fahrenheit, but if we change it to storing Celsius, external code would not need to change at all. There is still more to the topic of objects in JavaScript, but instead of continuing to cover the general topic of objects, in the next video we will cover a specific type of object known as an array.